Of SPSS, and in this tutorial we are going to show you how to conduct one-way ANOVA test and the interpretation of the test result. So the question is, when will a researcher conduct one-way ANOVA test? The answer is when the researcher has at least one categorical variable with at least 3 different or independent groups in it, and also there should be at least one continuous variable. The scenario is just like my dataset here. Here I have collected actually the IQ score of 20 different people, and these 20 different people are grouped into 4 groups based on their level of education. I have assumed the first group, which I defined as 1. They have passed their higher secondary exam. And the second group, which I assumed they have passed their graduation, I have defined them as 2. And the third group, I have defined them as 3 and assumed they have passed their post-graduation or masters. And the last group, I have assumed they have completed their PhD, and I defined them as 4. So now I want to know whether IQ score depends on level of education. And to do that, I can compare the means of the 4 groups, the mean IQ score of the 4 groups. And to compare the means of these 4 groups, we can conduct one-way ANOVA test. So let's see how we can conduct the one-way ANOVA test in SPSS. So at first we will go to analyze, then from compare means we will click on one-way ANOVA. In one-way ANOVA dialog box, you will find all of your variables listed on the left side. We'll pass the dependent variable in the dependent list. Here IQ will be in the dependent list because we want to know whether IQ score depends on level of education. So IQ score is the dependent variable here, and level of education or level variable is the independent variable or factor variable here. So level will go to in the factor box. Then we have to enter in the options in the right side of this dialog box, and we have to select homogeneity of variance test because before interpreting the main test result, we have to be ascertained about the type of homogeneity of variance the dataset is holding. So we should check mark this option, then click on continue, and then we have to enter the post hoc option. And here there are actually 2 frames. The first frame, it assumes that there is equal variances in the dataset, and the second frame, it assumes that there is no equal variances or equal variances not assumed. We will actually consider the first frame in the very beginning of this test. If we find heterogeneity in our dataset, then we will rewrite this program, and at the time of rewriting we will consider this second frame. The equal variance is not assumed. However, as we are in the very beginning of this test, we are firstly considering the equal variances assumed. And here there are a number of options. You can check any of these options, but I'm choosing only the 2 key here, and then click on continue, and lastly click on OK from the one-way ANOVA dialog box. Here is the outcome window. You will find several outcome boxes here, outcome boxes or tables, and you will firstly find the homogeneity of variance test table. And in this table, from this table you can determine what type of homogeneity your dataset is holding. Whether the dataset is holding homogeneity of variance or heterogeneity of variance. Here you will find homogeneity of variance test result based on the mean value, based on the median value, based on the median and adjusted degree of freedom, and based on the trimmed mean. But we will only consider based on median, because this is kind of standard practice to choose the homogeneity of variance test result based on median. And we have to look at the significance value of the homogeneity of variance test. The rules here is that if the significance value is greater than 0.05, then we are sure that the dataset is holding homogeneity of variance, or the variances of the groups, variances of the 4 groups are equal or equivalent. Otherwise, if the significance value is less than 0.05, then there is heterogeneity of variance in our dataset, or we can say the variances of the 4 groups are unequal or not equivalent or different. However, what we see here, the significance value of the homogeneity of variance test is greater than 0.05, which is 0.146. So we are sure that our dataset is holding homogeneity of variance, or the variances of the 4 groups are equal or equivalent. As we found the equality of variances among the groups in the homogeneity test, we will consider the other outcome tables in this outcome window. If we had found heterogeneity of variance, we would not consider ANOVA table or 2-key HST multiple comparison table, and also the homogeneous subsets. In that case, if heterogeneity of variance was found, in that case we would rewrite this program. We would choose equal variances not assumed, this frame, and with different other tests, the total OneWay ANOVA test would be written. However, as we found homogeneity of variance here, we will consider the other tables in this first run. So now we have to look at the ANOVA table, which actually concludes, which brings the conclusion of our test. And we have to look at the significance value here. Before interpreting this test result in the ANOVA box, we first keep in our mind that there are actually 2 hypotheses. One is null hypothesis, another one is alternative hypothesis. The null hypothesis says that the group means are equal or equivalent, and the alternative hypothesis says that the group means are not equal or not equivalent, or we can say the group means are different. However, the rules the rules related with any p-value or significance of any hypothesis test is that if the significance or p-value is less than 0.05, we have to reject the null hypothesis. Otherwise, if the p-value or significance value is greater than 0.05, we have to accept the null hypothesis. What we find here, the significance value or p-value of the test is less than 0.05, which is actually 0.000. So we are rejecting the null hypothesis. As we are rejecting the null hypothesis, we are accepting the alternative hypothesis, and alternative hypothesis says that the group means are different. This can be the conclusion of this test result, but we can scrutinize more just by looking at the post hoc tests. Here in this multiple comparison table, you will find the mean difference mean differences of the four groups in a paired way. Just like here what we see, the mean difference is presented in this column and the groups are here. And just by considering the upper two portions in this table, we can come to conclusion about the mean difference of each pair in our data set. Let's look at the interpretation here. Here what we see, the mean difference between higher secondary and graduates is 13, and this difference is statistically significant because the significant value is 0.043, which is less than 0.05. Then we find that the mean difference between higher secondary and postgraduates is 15.2, and this difference is also statistically significant because the significance value is less than 0.05. And the mean difference between the higher secondary and PhD holders is 40.2, and this difference is also statistically significant. Then what we find here in this second portion of this table, the mean difference between the graduates and the postgraduates is 2.2, and this difference is not statistically significant because the significance value is saying it's greater than 0.05, which is 0.958. And lastly, in this table, we find the mean difference between the PhD holders and graduates is 27.2, and this difference is also statistically significant. So from this multiple comparison table, what we find, only the mean IQ scores of the graduates and postgraduates, their mean difference is not statistically significant, and the other pairs, the other mean differences of the pairs are statistically significant. However, we have to look at the homogeneous subsets then. And in these homogeneous subsets, you will find the homogeneous groups are presented together. You will also find the heterogeneous groups also here. And look at the table actually. The mean value of higher secondary is 54.6 is written here, and it has no other groups with it. And then the graduates and postgraduates, these two groups are presented together one after another because the two groups are homogeneous. The mean IQ score of these two groups have the least difference. What we see here, the graduates mean value is 67.6 and the postgraduates mean value is 69.8. The difference is kind of 2.2 might be. So these two groups have the least difference between them. This is why these two groups are homogeneous subsets here. And lastly, we see the PhD candidates mean value, which is 94, and this PhD group has also no group with it. The graduates and postgraduates, these two groups are actually homogeneous. And you will also find the relative significance of the groups here. as the higher secondary has no homogeneous subset with it, I mean homogeneous group with it, so the significance value of higher secondary here is presented as 1. And the graduates and postgraduates, they are homogeneous subsets, and their I mean the mean difference, I mean the significance value of the mean difference of these two groups are presented as 0.958. Actually, we have already interpreted these results in the multiple comparison table here. So it's actually unimportant to interpret or keep in your research book or when you are analyzing. However, the PhD's significance value here is presented as 1 because PhD has no paired group, I mean PhD has no group with it, or PhD is not homogeneous with any other groups here. So this is the end of this video. I hope this video makes sense to you. However, if you have any question, please feel free to ask in the comment section. I will be very happy to answer them. And lastly, thanks for watching.